Welcome to our indirect proof. In previous lessons, you already learned how to write a two-column proof, and a paragraph proof, and a flowchart proof. Today, this new skill is quite different. In order to prove the desired conclusion is true, in the first example, the desired conclusion is x is not 9. So in order to prove the desired conclusion is true, we have to first to say it's false. And then we're going to reason logically until we reach a contradiction. Last, we're going to point out the desired conclusion must be true. Why? Because the contradiction proves the temporary assumption we just made is false. All right, let's follow these 3 steps. Step 1, we're going to make a temporary assumption that x is 9. Okay, that's our temporary assumption. Why we write x is 9? Because we try to prove x is not 9. Therefore, we're going to make a statement that x is 9. We temporarily assume this is true. Let's see what happened. If x is 9 and we're given y is 5, then x plus y is 9 plus 5. That is 14. However, we're given right here x plus y cannot be 14. Now we can say, oh, the desired conclusion, x is not 9, must be true. This must be true. Why? Because the contradiction proves the temporary assumption is false. X plus y is 14 if we say x you are 9. Okay, that's how we use this. Let's look at the next one. We're going to write indirect proof that the sum of 2 odd numbers is even. Remember step 1, we need to make a temporary assumption that the desired conclusion, it's right here, desired conclusion, is not true. So it's false. Therefore, step 1, we're going to write if the sum of these 2 odd numbers is not even, then it has to be odd. So I'm going to temporarily assume, let's write down the word temporarily assume, temporarily assume these 2 numbers I'm going to call A and B, okay? A plus B is odd. All right. Remember step 2? Step 2, we're going to reason logically until we reach a contradiction. Okay? All right. I'm going to rewrite A, this odd number. If A is odd number, A is odd, we can rewrite A as 2 times the number plus 1. Let me explain here really quick. So suppose A is 7. Isn't it true 7 is 2 times 3 plus 1? Suppose A is 9. Isn't it true is 2 times 4 plus 1? Okay, so this is our letter M, represent these numbers. Okay, and then we're going to rewrite B in the same form. So B is odd. Therefore, B is 2 times M plus 1. Now, the question asks us to add them. The sum is add. Okay, we're going to add A and B. So we're going to add A and B. We're going to say A plus B, A plus B. We're going to substitute. A is 2M plus 1. B is 2M plus 1. We have 2 times open close M plus 2. I just factor out this 2. All right, now we can say this part. If 2 times M plus n, the sum of the number, and add 2, then this number has to be even. Okay? So this pink one, the one we just highlighted, proved A plus B equals 2 times the sum of the 2 numbers plus 2. It must be even. But earlier, our temporary assumption says the sum of A plus B is odd. You see that? You see this desired conclusion must be true because the contradiction proves the temporary assumption we made on the first step is false. Therefore, the third step. Finally, we can say, yes, A plus B must be even in this case. All right, we are done. We finished proving. We used the indirect proof. Happy learning.